So we have 5 children. Each of them has a certain number of candies. 2 candies, 3 candies. 5, 1, and 3. Right, correct? Yes, that's right. And here we have 3 extra candies. See, here they are. What do we need to do here? We need to give each child these extra candies as well. And if after that the number of candies is greater than or equal to the maximum number of candies any child has, then we add true. If not, we add false. Let me show you again. So right now, initially, the maximum number of candies here is 5. The boy named Bill has them. Right. Now we take these extra candies and give them to Bob. Now Bob has 5 and Bill has 5. So both of them have 5 candies, which means we should put true because it says here that several children can have the maximum number of candies. So Bob has 5 and Bill has 5. So Bob will be true. Next, we give 3 candies to Anna. So Anna ends up with 6 candies. She also has the maximum number of candies, not less than 5, because 5 is the initial number we will use for comparison. So here we have 5. 5 is not less than the initial 5, so that's true. 6 is also not less than the initial 5, so that's true. Next, we get 8, then we get 4. Sam has 4 candies. 4 candies is less than what Bill originally had. So in Sam's case, we will set the result to false. And then we have the last child who has 6 candies. So as a result, all the children except Sam should be included in our final array. Result true, and only Sam will have false. That's what the conditions look like. And that's how you can interpret it based on some additional examples. So we've finished the first stage, completed the first step, solved the first piece of the puzzle. Let's move on. This is what our initial condition looks like. So here we have an array of numbers, integer, and we also have extra candies, which is also an integer. And we return a list of booleans. Let's start with the first phase. The first phase, which I call initialization. Here, based on what we know from our conditions, we need to write as much code as possible that will allow us to move forward. The first thing we know is that we have some maximum number of candies that one of the children has. In our case, that's Bill, he has 5 candies. And using this kind of manipulation, there's a function like this, max, which extracts the maximum value from our candies array, the maximum number. So max open parenthesis candies close parenthesis, and here we get 5. Thus, we store this value in the variable baseline max, the number that we will use for comparison. Here we have 5, and we got it using this kind of construction. Next, we create a variable called result flags, an empty list where we will add boolean values true or false when we compare the total number of candies. When we add candies here, add candies to this list, and we will compare it to this 5. And if the total number of candies Bob has is greater, we will add it as true. If it's less, we will add it as false. And finally, here it says that we need to return the result as an array called result. So we create this result and we will return it. So right now we don't have any logic yet, but in the first phase, I usually always start based on the keywords we have. I write as much code as I can at this stage. So let's move on to the second phase. We've finished the first phase. Let's see what we're going to do in the second phase. In the second phase, we will start a loop that will allow us to go through our elements, through the candies that our children have, using this kind of construction in Python for index current amount in enumerate candies. I can easily go through all of the individual elements of my array, and what's very convenient and incredibly useful is that I have direct access to the specific index, and I also have full access to the corresponding value. With this particular kind of elegant construction in Python, you can quite easily and efficiently access both the precise index and the exact value, making your code more robust and readable. If you just run a regular loop, then, depending on the programming language you use, you might only have access to either the value or the object or just the index. But in Python, there's this excellent solution, and I suggest you use it. This is also a great tool, as I always say in my lessons. It's an excellent tool that you can use when working with arrays. So if you haven't used this tool yet, give it a try, and it will definitely come in handy during interviews in the future. So let's move on. In the third phase, we will be working on the logic that should perform the filtering. Specifically, the number of candies. And basically, this logic is specified right here in our description. Right here and here. If we fully understand what is being asked of us, then writing it won't be a problem. So we move on to the final stage. And here, it turns out we finished the first two phases. And in the third phase, basically, you just need to implement the usual computational logic. That is, first, we calculate the new total. The new total is when we add the current number of candies to the extra candies. So at this stage, we add, for example, here we add 3 to 2, add 3 to 3, and so on. That's the first thing we do. And then we create a Boolean variable that checks something for us. This new total. Is it greater than the baseline or less? So here we added 5, added 2, and we compare. Is 5 less than this 5, the maximum, or not? And then, and so on for each element. With this kind of construction, it's very easy. We can simply understand it. So here it definitely has to be greater than or equal to. That means 5 is also included. And then, if we have true here, we add it to our result. We add it using this append construction, and we add true. If it's false, we add false. This append tool is also one of the tools you need to understand how it works in a list. I've already covered it in previous lessons, as I mentioned earlier. All these tools, like enumerate and append, keep coming up. So, if you use these tools when solving problems, you'll also use them directly in interviews and elsewhere, in other types of problems. That's why the more problems you solve, the more tools you can use and remember. That's it. So, that's what the solution looks like. It's very simple and clear. There's nothing complicated here. No tricky moves or manipulations. That's why we've gone through these first 2 or 3 phases together. In the first phase, we did the initialization. In the second phase, we created the loop. And in the third phase, we added the logic. So we've taken 3 small steps that allowed us to get the result. And we solved the puzzle by breaking our overall task into 3 smaller parts. As a result, we ended up with this solution. But don't turn off the video yet. Let me show you something else. This is what my solution looks like with a lot of logs. This allows me to see how my algorithm works. And here, as you can see, everything is very clear. That is, we have our first child under index 0. He has 2 candies. 2 plus 3 equals 5. Our validation is 5 greater than or equal to 5. True. And you and I add the result. And so, you see, we have our array, the result is increasing. And here, for the 4th child, we get false, because 1 candy plus 3 equals 4, and 4 is less than 5. That's why we place false. As a result, we have the final result in C2, except for the 4th child. Once again, I'm showing my logs. You can write your own, but I still recommend writing such detailed logs because it helps you understand the task itself. Here, I also wrote everything down for myself, how it all looks. And naturally, I remembered it well. I also save all of this in a file like this. See, here I have a special enumerate. These are the techniques I use. There's a brief description here. And this file keeps growing from previous tasks. Well, that's it. And here we have the very first one from the first task, append. It's here as well. I also recommend that you make all these notes for yourself, somewhere in a notebook, so you can look them up later and review them before an interview. If you'd like to get my notebook, follow the links. You can get the notes and logs that I use myself. And of course, going forward, all these tasks that I solve, I will be posting all of them. Be sure to subscribe to my page and check the links in my profile. There you'll find a huge amount of additional materials and full reviews that will save you time when studying algorithms.